Today's topic is construction of circles. We can expect one question 3 to 4 marks in section B mostly, but it can come in section A also because it is quite easy. It can come fused with the topic of locus. Actually, the two topics are heavily interconnected. So let us see. We presume that you are having a knowledge of how to draw angles like 60 degree, 120, 135. All these were covered in 6th and 7th standard. So we won't put in time in doing those things. Any angle which is a multiple of 15 degrees can be drawn with the help of a compass. But if an angle is not a multiple of 15, like something like 100 or 103 degrees, then you will have to use a protractor for the same. Okay. Question 1, and before we start, remember any construction sum is always to be started on a fresh page because we do not know how the finished construction final product would look like and how much space it would occupy. So always start the construction on a fresh page and start from the center of the page so that it is bound to fit in. Rough diagram you should always draw to get an idea, so as to develop that imagination. Okay, I can locate my point P like this, Q like this, but it does not carry any marks as such in the exam. And pencil of course has to be used for construction. Steps of construction not to be written in the exam. Okay. Question 1. Draw a regular hexagon of side 3 centimeter. Regular hexagon of side 3 centimeter. Construct a circle that passes through all the vertices of the said regular hexagon. We'll come to the second part a little later. Let's first draw the regular hexagon. There are different ways of drawing regular hexagon. The safest way to draw the regular hexagon is what I am teaching you. If you draw this, you will not lose any marks in the board exam. Other techniques may not be accepted. Draw a segment 3 centimeter direct with the help of a scale. It's an opening segment, so we can draw directly with the help of a scale. Now in a regular hexagon, each interior angle is how much? 120 degrees. So what we do is, with this as my point, we draw a semicircle of any convenient radius. See to it that your arcs are not too big or not too small, else there is too much of overlapping and crowding. Then with this as the center, same previous settings of the compass, cut 60 and 120. Same procedure, repeat on this side. Now this is 3 centimeters, so in the regular hexagon naturally all sides are equal. So with this, cut 3 centimeter here with the compass, take an arc of radius 3 on a scale, cut it. Here also cut 3 centimeter. With this as the point, again draw 60 and 120 degree angle. Repeat the same procedure here. With this as the center, cut an arc of radius how much? 3. Same with this as the center, cut an arc of 3. Join. This becomes our regular hexagon. So 4 times we have to draw 120 degrees. Now what happens is, in the process of drawing 120 degree angle 4 times, there will be slight error which will be reflected in this side. So the last side on which we have no control, if you measure, you may find a difference of 1 or maybe even 2 millimeters plus or minus, which is okay. Because 4 times when you are drawing, the whole error, minor error completely compounds onto this side, and this side takes the brunt of all your minor errors, and you will have this side not turning out to be 3, it would be plus or minus 2 millimeters, which is fine. Of course, if you are very accurate and precise in your drawing, this obviously would be 3, but it is not worth the efforts of cancelling this and drawing it again. There is no guarantee that in the second time you will get correct, because constructions are skill based, and even if overall 1 mark is cut for not being accurate, it is fine. But to save that 1 mark, again spend 5 to 7 minutes, not worth the efforts unless you have sufficient time left in the exam. Okay. Now construct a circle that passes through all the vertices of the said regular hexagon. So what will this be? Circumcircle. So either the question can be framed like this, or they can say construct a circumcircle for the said regular hexagon. Anyways, the question can be framed. So now we need a circle which passes through all the vertices. So 1, 2, 3, 4, 5, 6. A regular hexagon will have 6 vertices. We need a circle that will pass through all the vertices. So what do? We take the perpendicular bisector of any two sides. We take the perpendicular bisector. So I will take perpendicular bisector of this side with this point as my center, radius more than half, draw the arcs on either side. Now with this as the center, pointed edge of the compass here, and the same settings unchanged, same previous settings, cut these arcs. Join. You will get one perpendicular bisector. Repeat the procedure for the second side. You can take this side, you can take this side, absolutely no problem. The two perpendicular bisectors will meet at some point O. Now with O as the center and OA as the radius, with O as the center and OA as the radius, trace out a circle. O as the center and OA as the radius, or OB as the radius, no problem. Trace out a circle. The circle will pass through all the 6 vertices. Now when you actually do this construction, as I told you, it is skill based, it is quite possible that it may pass through 4 or 5 vertices. It may not pass through the 6th vertex. That's fine. In the board exam, either you will not lose any marks, or at most 1 mark will be cut. But it is not worth cancelling it and drawing it again, spending 5 to 7 minutes to save that 1 mark. In that 5 minutes, we can attempt another question of 3 to 4 marks. Okay. So keep in mind, it's okay if the circumcircle touches say 4 to 5 vertices out of 6. If it is touching 5 out of 6, it is excellent. Okay. And if you are very, very precise, then it will touch all 6. This is the way a standard question can be framed. This question can be modified also. One way is they will say draw a circumcircle. Other way is like this: construct a circle that passes through all the vertices of the said regular hexagon. Another way of framing would be construct a circle whose center is equidistant from all the vertices, equidistant from all the vertices of the regular hexagon. This also points towards the circumcircle. So anyway, the question could be framed. So we have finished question 1. Question 2. Construct a triangle ABC such that BC is 7.3 centimeter, angle B is 105 degrees and angle A is 15 degrees. Construct a circle touching all the sides of the triangle. Now we will see, to get a triangle, we'll draw a rough figure to see how it is going to look like. This is BC 7.3. Okay. B is 105. It's an obtuse angle. Now angle A is given to us 15. B is 105. This is 7.3. The problem is angle A is given. Now how do I draw angle A? Because A is not fixed. A could be here, A could be here, A could be anywhere on this line. Even CA is not given, the distance. Like if CA was given, then there is no problem. We could have taken C and cut an arc. Say CA was say 10, we could have cut an arc. But CA is also not given. Angle A is given as 15. Now what to do? So see, let's take a figure like this. This angle is 15 degrees. We know that sum of the angles of a triangle is 180. So it is 105 plus 15, that gives us 120. So this angle will be how much? 60 degrees. So if we draw this angle as 60 degrees, automatically this angle will become 15 degrees and we would succeed in drawing the triangle. So remember, in construction sums, we are permitted to work out certain angles. If the sum is such that it cannot be drawn directly, we are very much permitted to work out certain angles. You need not show the calculation for it. We can just keep it in our mind and draw the triangle. So this is the importance of a rough figure, though this would explicitly not carry any marks. So what do? We first draw BC as 7.3. Since it is an opening segment, we can draw directly with scale. Angle B is 105. Now 105 degrees is a multiple of 15. That means it can be drawn with a compass. In the exam, if you are unable to use compass for drawing angles, it is fine if you draw it with a protractor, but you are bound to lose at least 1 mark overall for sure. But then you will be able to complete your construction rather than thinking how do I draw B as 105 with a compass and just stopping here. It's better you take a protractor and draw it. You will be able to complete your construction, and 1 mark for sure you will lose at least for not using a compass to draw the angle, but then you will be able to reach the end of the construction. So that makes sense. Okay. Now how to draw 105 degree with compass? By this time you are well aware how to draw 60 and 120 degrees. So we draw 60 and 120 degrees. We bisect 60 and 120. Keep a compass here. At this point, radius more than half, draw the arc. Keep the compass here, same previous radius, cut the arc. So you will get 90 degrees. Do not break your head in which lines should come light, which lines should come dark. All those things are not required in maths constructions. You can draw the full diagram in equal, moderate intensity, absolutely no problem. Otherwise you keep wondering which lines should come dotted, helper line should come dotted, which line should come dark or complete. Nothing of that sort. Just draw the full construction with equal, moderate intensity. No marks will be cut. Now this is drawn 90 degrees. So we have this point as 60. This is 90. This is 120. If we bisect 90 and 120, what we will get? Let us see. 90 plus 120 upon 2, bisect. So it is 210 upon 2. Wow, this is 105. So if I bisect 90 and 120, we will get our 105 degree angle. So let's do that. Bisection we know, very trivial. So this is 90, this is 120 degree arc. Bisect it. put the pointed edge here, radius more than half, draw the arc, put the pointed edge now here, same previous radius, cut the arc. So we have drawn our 105 degrees. Okay. As discussed in the rough diagram, what should be our angle C? Now A to we can't locate here. So I can't draw A as 15 degrees. So what we do? C we draw it as 60 degrees because as we explained in the rough diagram. Stretch it wherever it meets this line. Be careful, don't take this line. This is 90 degrees. This is your 105 degree angle. So this will be our point A. So now we have got triangle ABC, and this angle A, if you measure, it will be automatically 15 degrees. If it is 1 degree here and there, no problem. Construct a circle touching all the sides of the triangle. Construct a circle touching all the sides of the triangle. What will this be? In circle. See, if this is my any random triangle, this will be the in circle, touching all the three sides. To draw an in circle, we need angle bisectors of any two angles. We need the angle bisectors of any two angles. So say we take this angle, we bisect it. Now this arc is already drawn, so we can bisect this angle. This as the center, radius more than half, draw the arc. Then with this as the center, this as the center, same previous radius, cut the arc. So we have drawn one angle bisector. Now the other angle bisector, we could take off this angle ABC. Be careful, don't try to bisect this. This is 90 degree. This doesn't form a part of the triangle. Our triangle is obtuse angle triangle. So triangle is like this, ABC. So now what we will do? We will bisect 105 degree angle. This is our 105 ka point. This is 0. This was how much? 60. So with this as the center, so remember we are bisecting now 105 degree angle because to draw in circle, we need angle bisectors of any two angles. With this as the center, radius more than half, draw the arc. And with this as the center, this is a line for 105 degree. With this as the center and the same previous radius, cut the arc. So now we are going to bisect 105 degree angle. Okay. Now actually in real life when you draw this, it will pass from here. It will pass from here because 0 plus 105 upon 2, that works out to be 52.5. And this arc was how much? 60 degrees. So naturally, so I'll change it. Now to get the in circle, we need angle bisectors of any two angles. So one we have drawn here already. Other one we can bisect this angle ABC. Take care, do not bisect this 90 degree angle because it doesn't form a part of the triangle. Our triangle is an obtuse angle triangle ABC. So this is 0 degrees. This was the arc for 60 which we drew long back. This was 90 and this was our 105. So we will have to bisect 0 and 105 degree angle, so that whatever it is we are not concerned, but it will be less than 60. So although I am drawing it in rough, I am taking care of it. With this as a center, radius more than half, draw the arc. With this as the center, same previous radius, cut the arc. So we have drawn the angle bisector for 105 degree angle. Naturally it will pass through here, it won't pass from here because this is 60 degree arc. So 105 upon 2 is like 52.5. So it will pass before that. Okay. Let this be, say, I. Now the common mistake made by students is they put the pointed edge here of the compass, take this distance approximately on a compass and try to trace out a circle, which is not going to work. We will have to get the perpendicular distance. We will have to get the perpendicular distance. So for that, there is a technique how to drop a perpendicular. So we'll just show it here, it becomes easy. Suppose this is a line and there is some random point here. Okay, we need to drop 90 degrees, simple perpendicular. So what do we do is, from this point, we draw like moon like this, and with this as the center, radius more than half, draw the arc. With this as the center, same previous radius, cut the arc. Join. This angle will become 90. This is a technique of dropping a simple perpendicular from any given point to a given line. Same we will replicate here. Now from I we need to drop a perpendicular to BC, not perpendicular bisector, perpendicular only. So from I, with I as the center, draw an arc cutting the base in 2 points. We could have drawn on this side also, there is no problem. Any side you can draw. Once I have drawn this half moon, cutting the base in 2 points, with this point, radius more than half, now this becomes my segment. So with this point, radius more than half, draw the arc. With this point and the same previous radius, cut the arc. Join by scale. This angle will become 90. Now this is a proper perpendicular which we have drawn. Say we name this point as Z, this point. Now with the pointed edge on I, pointed edge of the compass on IZ as our radius, we trace out a circle. It will touch all the 3 sides. If it does not touch all the 3 sides, it is touching 2 sides, it is fine. It is not worth redrawing to save that 1 mark which you probably may lose because of inaccuracy. At times, even if it is touching 2 sides, no marks are cut. Okay, if it is touching 2 sides properly. So we have successfully drawn our in circle. Comfortable with this? This question can also be modified little. Instead of saying construct a circle touching all the sides of the triangle, it can also be framed like construct a circle whose center is equidistant from all the sides of the triangle. Isn't it? Now this radius and this radius would be the same. Construct a circle whose center is equidistant from all the sides of the triangle. This would hint towards in circle. So there are various ways of framing the question. One way is this, direct. Other way is saying draw an in circle to the given triangle. Third way is construct a circle whose center is equidistant from all the 3 sides of the triangle. So here we are connecting it to locus. If it is equidistant from all the 3 sides, the sides are intersecting. So then we will have to draw angle bisector. If you remember locus, you can bring in. So that's why I said in the beginning, this topic and locus are actually very much connected. So we have completed this, and now we just have 2 more questions for this topic to get over. Question 3. Construct triangle ABC in which base BC is 6 centimeter, AB is 5.5 and angle ABC is 120 degrees. So first let's draw this triangle. Now that way a triangle has got 3 bases, but here they have said base BC. So we will take BC first. It's an opening segment, so we can draw directly 6 centimeter with the help of a scale. Angle ABC is 120 degrees. So you are well versed with drawing 120 degrees now. So we have drawn, okay, 120 degrees. AB is 5.5. So with now we cannot take directly 5.5. So with B as the center and 5.5 as the radius, we will cut an arc. So that will give us our point A. This will give triangle ABC. This will give you 1 mark. Construct a circle circumscribing the triangle ABC. Construct a circle circumscribing the triangle ABC. Circumscribing the triangle means circumcircle. So we will have to draw a circumcircle. See, construct a circle circumscribing the triangle ABC. So it will be naturally a circumcircle. Okay. If it was an incircle, suppose, I'm just discussing the variants of this problem. This is say triangle ABC, some random triangle. And this is my incircle, touching all the sides. So how can this question be framed? Construct a circle inscribed in the triangle ABC. Inscribed. So here the circle is inscribed. So this would be incircle. Here what have they asked? Construct a circle circumscribing the triangle ABC. That means it is the circumcircle. So for circumcircle, what do we need? Perpendicular bisectors of any 2 sides. So I will take BC and AB. B as the center, radius more than half, draw the arcs on either side. With C as the center, with the same settings of the compass, previous settings, cut the arcs. Now take AB. Repeat the procedure, same what you did here. Perpendicular bisector of AB. We drew perpendicular bisector of BC, now we are drawing perpendicular bisector of AB. It's an obtuse angled triangle. So you will have to stretch your perpendicular bisectors. They will meet outside the triangle. So where are they meeting? Okay, here. Now let this be say O. Now with OA as the radius or OB as the radius or OC as the radius, trace out a circle. With OA as the radius or OB as the radius or OC as the radius, trace out a circle. It will nicely pass through A, B and C. If it slightly does not pass through one of the points, leave it, no problem. This is now done till here. So this part is done, this part is done. Let's see this part now, final. Draw a cyclic quadrilateral ABCD so that D is equidistant from B and C. First of all, let's understand this word cyclic quadrilateral. You might have already done the topic of circles. So you are aware what is a cyclic quadrilateral. Say this is ABCD. This quadrilateral is said to be cyclic because all the 4 vertices of the quadrilateral lie on the circumference of a circle. So ABCD would be a cyclic quadrilateral. Of course, this is not the precise definition of a cyclic quadrilateral. It's one of the definitions. You would have done topic of circle, so you are aware that opposite angles should also add up to 180. Now, if you have a quadrilateral like this, PQRS, here I have not drawn a circle, but I am telling you this is 150 degrees and this is 30 degrees. Can this quadrilateral be cyclic? Yes, because 150 plus 30 is giving us 180. So this quadrilateral is also cyclic, though a circle is not drawn, but still it is cyclic quadrilateral. If we wish to draw a circle, it is very much possible. Now, coming in the context of this problem, draw a cyclic quadrilateral ABCD such so that D is equidistant from B and C. Recall your locus concepts. D is equidistant from B and C. What are B and C? Two fixed points. Locus of a point equidistant from two fixed points is the perpendicular bisector. So as mentioned earlier, this topic, though it is construction of circles, it can very much confused with locus concepts. So draw a cyclic quadrilateral ABCD so that D is equidistant from B and C. So what we will have to draw? Perpendicular bisector of BC, which incidentally we had drawn before only for the subpart 1. So that is drawn. Now D can lie anywhere here because any point on the perpendicular bisector will be equidistant from two endpoints. But they have said draw a cyclic quadrilateral. That means point D should also lie on the circumference of the circle, and also it should lie on the perpendicular bisector because the condition is D is equidistant from B and C. Now B and C, segment BC ka perpendicular bisector is already drawn. We will have to just stretch it so that it meets the circumference of the circle, and this will be our point D. So now A, B, C, D. So simply join with scale. So we will get our quadrilateral, cyclic quadrilateral ABCD, which takes care of the condition that D is equidistant from B and C because it is lying on the perpendicular bisector of segment BC, and D is also lying on the circumference of the circle. So all things are taken care of. Question 4 and the final question for this topic. Interesting question. Draw a line segment AB, line segment of length 5 centimeter. Mark a point C on AB such that AC is 3. Okay. So let's first execute that. Line segment AB 5. Opening segment we can draw directly 5 centimeters. Mark a point C on AB such that AC is 3. So C has to be marked on AB itself. This is 3. So you will have to cut an arc of 3 centimeters. You cannot take 3 centimeter directly. Opening segment you can take directly with the help of a scale, but not the subsequent segments. So this is say point C, and AC is 3 centimeters. Construct a circle of radius 2.5 centimeter passing through A and C. So will AC act as the diameter? Not necessary. They never said with AC as the diameter. They said construct a circle which passes through A and C and radius is 2.5. So consider this diagram. This is A and this is C. This is center of a circle and this radius is 2.5. OA is the radius 2.5. So naturally OC also will be 2.5, radii of same circle. Is AC the diameter? No. AC can also be a chord. Yes, diameter is the longest chord, but we cannot take it in particular that AC has to be the diameter. It could be any ordinary chord. So take care of this. Now, how do we draw a circle? We cannot randomly just take it and draw it. Radius is specified 2.5. So this rough diagram gives us a clue. If AC is my chord and I need the radius to be 2.5, so AO and CO would be equal naturally, radii of same circle. So what we do is, with A as the center, radius 2.5, we draw an arc. And with C as the center and the same radius, with C as the center and the same radius, we draw an arc of how much? 2.5. So the two arcs say meet here. So this would be the center of the circle. Now once we locate the center of the circle, we can easily draw the circle. Put the pointed edge of the compass on O and radius OA, because the problem, if you have to draw a circle, you need to locate its center. So we have located the center now because the radius was given. So from A 2.5, from C also 2.5. So now the center of the circle is now located. So drawing a circle is not difficult. So we have successfully drawn a circle passing through A and C. At the same time, the radius is also 2.5, so things are taken care of. So this part is now done. This part was done long back. Now, construct the two tangents to the circle, this circle, from the external point B. So you remember we have these questions how to draw two tangents to the circle from an external point. So instead of asking this as an isolated question, it has been beautifully blended with this part. Now how do we draw the two tangents to the circle from a given external point? Let us try to get a sketch, rough sketch. If this is the circle and this is, say, an external point B, the two tangents would be like this. Yes, so say BP and BQ would be the two tangents from an external point. We can draw two tangents to a circle from a given external point. But we cannot simply take a scale and draw, because the human eye cannot judge the point of contact. So there needs to be some technique of drawing. So from point B we need to draw now two tangents. So what we do is we join OB with a scale. Once we get segment OB, take the perpendicular bisector of segment OB. You very well know how to draw the perpendicular bisector. So the perpendicular bisector of segment OB is now drawn. So let this point be, say, P. P is used anywhere else? No. Okay, so we can use this. Now with P as the center and PO as the radius or PB as the radius, trace out a circle. The newly drawn circle, oh, it has not come so well. Let me make it a little good. The newly drawn circle meets the old circle at two distinct points. the newly drawn circle meets the old circle at two distinct points. Locate those points. Here and here. So remember, the newly drawn circle meets the old circle at two distinct points. Locate those points wherever the two circles meet. And from point B, take a scale and join at those two distinct points. So say BX and BY. BX and BY are the two required tangents drawn to the original circle. I repeat once again. You join OB, take the perpendicular bisector of OB. You will get the midpoint, say P. With PO as the radius or with PB as the radius, trace out a circle, fresh circle. The newly drawn circle will intersect the old circle at two distinct points. Locate those 2 points, simple by observation, and from this external point B, join with a scale. So BX and BY, say it's like one circle, second circle. So these two become my two distinct points, and from the external point B, you join. So BX and BY would be the two required tangents drawn to the original circle. Finally, the question says measure and record the length of the tangents. Now, as we know, tangents drawn from an external point to a circle would be equal in length. But because this is construction, when you actually measure, either they will turn out to be equal, that's best, I mean they have to be. But if there is some error in your construction, your hand has slightly moved and all, there could be a difference of 1 millimeter between the two tangents. No problem in that. So I suppose the length of the tangents is working out to be 3.2 centimeters. Okay. Important tip, when you measure by scale, suppose this is 3 and this is 4 on a scale. So this is 3.1 and this is 3.2. While measuring, if you get it in between 3.1 and 3.2, we cannot write 3.15. It will naturally be marked wrong. How can scale give you up to 2 decimal place of accuracy? What is the least count of the scale? 0.1 centimeter or 1 millimeter. So the scale can give you 3.1 or 3.2 or 3.3. But while measuring, we have no control over the segment. It is already drawn. So if it comes in between 3.1 and 3.2, no problem. While reporting the answer, it should be reported as either 3.1 or 3.2, but it would be meaningless to report the answer as 3.15 because we cannot go better than the least count of the instrument what we are using. And you will have to report the answer, say BX is 3.1 centimeter. Now when you measure BY, maybe it differs by 1 millimeter, it's okay. So that is say 3.2 centimeter. So this completes the sum. This sum was asked in 2016 board paper. Completes the topic. Thank you.